Hello students, back to the Tangential physics classes. Today I will deliver second lecture on circular motion. And first lecture was some relationship between rotational and linear variables. Now it's a lecture on directly on circular motion, uniform circular motion, then non-uniform circular motion. And I think this will be complete in this lecture, total circular motion. Okay. Number one, uniform circular motion. Uniform circular motion. Uniform circular motion. What is uniform circular motion? You see particle here moving in a circle of radius, the center of radius r. Circle has a radius r and the particle has speed v. So how to define uniform circular motion? The definition of uniform circular motion is that a particle moves in a circle of constant radius and constant speed. When the speed of the object moving in a circular motion is constant, then you say it is a uniform circular motion. But don't think that it is a uniform motion. Uniform motion means velocity constant. In uniform circular motion, velocity is not constant. It is the speed which is constant. So, uniform circular motion is an accelerated motion. Number one, that's the first point that I can talk about the uniform circular motion. Particles have been moving in a circles. If their speed is constant, then we say they are moving in a uniform circular motion. So first point that I want to talk to you is that a uniform circular motion is an accelerated motion. Yeah, accelerated motion. And for acceleration, you need always a force. So, in uniform circular motion, a particle moves in a circle with constant speed. There is a force acting on the object. And the direction of that force and the direction of the acceleration is towards the center of the circle. Force is towards this. But the particle is moving with speed and force is in this direction. Force. So, B, the acceleration and force. The net acceleration and force is towards the center of the circle. तो ये फोर्स सर्कुलर मोशन में जो फोर्स होता है पार्टिकल पर होना भी चाहिए क्योंकि वेलोसिटी चेंज हो रहा है, स्पीड कांस्टेंट है और ये फोर्स सेंटर की ओर हमेशा होता है और सेंटर की ओर हमेशा होता है तो इसका मतलब दिस फोर्स शुड बी परपेंडिकुलर टू वेलोसिटी. So see, force which we call a centripetal force, center seeking force, because that's the name, because it is towards the center, therefore it's called centripetal force. Centripetal force is perpendicular to velocity and acceleration is also perpendicular to velocity. That is very important. So when the force is always towards the center, how much is the acceleration which is towards the center? Which is the acceleration, particle is moving in a circular motion with uniform speed. There is acceleration towards the center. How much? What is the magnitude of that acceleration? Of course, the acceleration direction changes always. You see, direction of acceleration is here, and then it is here in this direction. First, it was here, here, and here. So, direction of acceleration continuously changes. That is true. But it's called centripetal force because it always seeks the center. D point. The force is normal to velocity. The force is normal to velocity. Acceleration also normal to velocity because force and acceleration have the same direction. Therefore, this force, which we call a centripetal force, does not do any work on the object. Because when force is perpendicular to velocity, no work is done. So, the centripetal force does not do any work. Does not do any work. It does not do any work. E. If it is not doing any work, that means kinetic energy is not changing, because after all, what is the work energy theorem? The work done is equal to change in kinetic energy. When no work is done on the object moving in a circle, therefore there is no change in kinetic energy. Change in kinetic energy is equal to 0 because work done is 0 by the centripetal force. Okay. And what are the other features of this uniform circular motion? What are the other features? A point. Does momentum change in a uniform circular motion? The answer is yes, because momentum is a vector and it is mass into velocity. Velocity changes, their momentum, therefore momentum also changes. Momentum changes. But of course magnitude of momentum जो है, that is constant. Because magnitude of momentum means m magnitude of velocity, that is constant. Velocity का magnitude जो है वो constant है in uniform circular motion. I repeat, don't forget that in uniform circular motion, speed remains constant, but velocity changes. The force is toward the center, and acceleration is also toward the center. All right? So, in order to move anything in a circle, किसी चीज को भी circle में घुमाने के लिए, you must create a force toward the center. Otherwise, that will not move in a circle. Earth moves around the sun. The force is gravitation. That provides this centripetal force. Right? Now, what is the magnitude of this acceleration? Or what is the magnitude of the force which is required to move a particle in a circle? कितना फोर्स चाहिए हमें ताकि एक पार्टिकल को हम सर्कल में घुमाएं? दैट इज द रिक्वायरमेंट. लेकिन उस रिक्वायरमेंट को कोई भी एक्सटर्नल एजेंट, रियल एजेंट प्रोवाइड करना चाहिए. What is the magnitude of acceleration? Of course, the direction of acceleration continuously changes. This is the direction, this is the direction, this is the direction, continuously changes. But magnitude of acceleration in uniform circular motion remains constant. Magnitude की बात कर रहा हूं, direction तो change होता है. That is v square by r. Square of the speed divided by the radius of the circle. It can be derived in a moment within 2 lines, but I'm not interested in deriving because it is the lecture for NEET students. What is the GHI? What is the force needed? Centripetal force needed for uniform circular motion. Uniform circular motion is mass into this magnitude of acceleration. Mass into magnitude of acceleration. Or FC is equal to m by r. इस स्पीड को आप क्या लिख सकते हैं? r ओमेगा का स्क्वायर. That is m is r square, 1r gets cancelled, r omega square. You can write centripetal acceleration mr omega square, or you can write centripetal acceleration mv square by r. Omega is angular velocity, and the relationship between speed and angular velocity is r omega. Speed is equal to r omega. That is all. Everything about uniform circular motion. So again, I will repeat. Uniform circular motion. In uniform circular motion, what is important is that particle speed is constant. Particle moves in a circle, therefore velocity changes. Velocity changes, therefore there is acceleration. What is the direction of that acceleration? That is always towards the center of the circle. Therefore, for creating any kind of acceleration in the particle moving in a circle, you need a force. And that force is called centripetal force. That force should be again towards the center. Why? Because acceleration is also towards the center. How much is the acceleration magnitude? V square by r. How much is the force magnitude? That is m v square by r. But v can be converted into r omega. Therefore, it is m r omega square here. The momentum of the particle moving in a circle changes. Why? Because there is force. Momentum has to change. But magnitude of momentum remains constant because the speed remains constant. This is all about uniform circular motion. But who provides the centripetal force to make a body to move in a circle? Who provides that? Some external agent must provide that. Some real force should provide that. किसी external agent को provide करना पड़ेगा. जैसे भी आप देखो, किसी चीज को भी अगर आप सर्कल में घूमते हुए देखोगे तो समझो सेंटर की ओर कोई ना कोई एजेंट उसको खींच रहा है, पुल कर रहा है। अगर आपके पास स्ट्रिंग है, किसी चीज को यू whirl it around your head, it is the tension which creates that centripetal force to move the body in a circle. Earth moves in a circle around the sun. That means it's a gravitational force. If you are a chemist, you must be a chemistry student. Electron revolves around the nucleus. It is electrostatic force between the nucleus and the electron which provides this mv square by r force to move a particle in a circle. तो पार्टिकल खुद ही सर्कल में नहीं घूमेगा unless there is some external force which provides this mv square by r requirement. Okay, number second, ये था यूनिफॉर्म सर्कुलर मोशन के बारे में सारा कुछ इंफॉर्मेशन जो मैंने आपको दिया है. अच्छा, सेकंड, a particle, let me solve an example on this. A particle moves in a circle of radius 10 centimeters and its time period to complete the circle is 4 seconds. What is the centripetal acceleration? Centripetal acceleration. क्या है ये क्वेश्चन? एक पार्टिकल जो है वो सर्कल में घूमता है विद कांस्टेंट स्पीड ऑफ कोर्स. A particle moves in a circle of radius 10 cm and its time period is, जब टाइम पीरियड हम डिफाइन करेंगे as 4 seconds, समझो कि ये पार्टिकल जो है यूनिफॉर्म स्पीड से मूव कर रहा है. Otherwise time period will not be the same in every circle. So it is a uniform circular motion. So how to solve the question? Okay, it's a particle like this and moves in a circle like this, and it is radius is 10 centimeters and its speed I don't know because that I have to calculate here. Speed I don't know, but time period he gives. Okay, what is the formula for centripetal acceleration? V square by r, right? And what is V square? That is r omega square divided by r. That is 1 r gets cancelled, r omega square. That centripetal acceleration is r. What is omega? That is 2 pi by t whole square. And what is centripetal acceleration? That is r is 10 centimeters. Okay, it's 10 centimeters. And should we make it meters per second? Okay, we'll keep it centimeter per second square. SI CGS system you can use and can use SI system, but the radius is given in centimeters. I can convert it into meters. Okay, let me convert it to meters. 10 raised to power minus 2 meters into, it is 4 pi square by t square. It is 10 into 10 raised to power minus 2 into 4. It is 10 again, pi square is 10 again, divided by what is t square? That is 16. 10, this cancels off, it is 4. It is AC is equal to 1 by 4, that is 0.25, yes, meter per second square. That is the answer. As a particle moves in a circle of radius 10 centimeters, its time period to complete the circle is 4 seconds. What is the centripetal acceleration? तो ये है centripetal acceleration. So इस particle का जो acceleration है सेंटर की ओर वो 0.25 मीटर पर सेकंड है. तो अगर फोर्स देखना पड़ेगा, how much force is pulling this object towards the center, तो उसका क्या है, उसको कैसे निकालेंगे फोर्स को? तो फोर्स के लिए इस बॉडी का मास भी दिया होना चाहिए. अगर मास दिया है समझो आप फोर्स भी निकाल सकते हो. ठीक, ओके, चलो, दिस इज वन पार्ट. ओके, लेट मी क्विकली गो टू द नॉन यूनिफॉर्म सर्कुलर मोशन because it is quite related. It is quite related to uniform circular motion and non-uniform circular motion में थोड़ा ही फर्क है. थोड़ा ही कुछ और चीजें याद रखनी है। नंबर थर्ड, नॉन यूनिफॉर्म सर्कुलर मोशन। बस इतना कुछ, नॉन यूनिफॉर्म सर्कुलर मोशन। थोड़ा सा फर्क है, थोड़ा सा हमें और याद रखना पड़ेगा और ये सारा कंप्लीट हो जाएगा। हैव ए लुक, देख लो अच्छी तरह से। पार्टिकल मूव्स इन अ सर्कल, ये स्पीड है और ये सर्कल का रेडियस है। इफ आई आस्क यू दैट इट मूव्स विद अ कांस्टेंट स्पीड, आप कहेंगे इट इज एक्सेलरेट टुवर्ड्स द सेंटर और सेंटर सी, and that acceleration magnitude is constant, but that acceleration direction changes all the time. It's always towards the center. If it is a constant speed, but that is uniform circular motion. So what is non-uniform circular motion? Please, non-uniform circular motion mein sirf or sirf when this speed also changes. So it is a circle, it is completing a circle, at the same time its speed also increases. So in non-uniform circular motion, speed changes. That is, magnitude of velocity is not constant. So if magnitude of speed is not constant, that means there is acceleration in this direction, tangential acceleration. So there, obviously, if speed changes, there is tangential acceleration, that I have already told you in the first lecture. The tangential acceleration is just the rate of change of speed. So there is tangential acceleration. But at the same time, there is centripetal acceleration because it moves in a circle. So in non-uniform circular motion, a simple statement, in non-uniform circular motion, the acceleration has both the components, tangential component and radial component. Whereas in uniform circular motion, there's only radial component. Radial component means one along the radius of the circle. That I have already told you, that is towards the center of the circle, centripetal acceleration. So uniform circular motion में सिर्फ radial component है, v square by r acceleration. लेकिन non uniform circular motion में tangential part भी है, which is dv by dt. इसका मतलब जो net acceleration है in non uniform circular motion, that's not towards the center. After all, it has now two components. Therefore, net acceleration जो होगा, that will be like this, A net. If that makes alpha with this tangent, with the tangent or with this, whatever you want to do, okay, let's say it is alpha. So what is tan alpha? B. The tangential acceleration is dv by dt, rate of change of speed. मैं लिखूंगा, but otherwise you will think that is rate of change of velocity. It is rate of change of speed. Rate of change of speed. And centripetal acceleration again continues to be what it was in uniform circular motion. उसमें कोई फर्क नहीं आया. That is v square by r, or that is r omega square. What is net acceleration? That is root of this component square plus this component square. As you know, if two vectors are perpendicular to each other, net is sum of the two squares. So it is dv by dt whole square plus इसका स्क्वायर करो या इसका स्क्वायर एक ही बात है, और ओमेगा स्क्वायर होल स्क्वायर. What is this alpha? Tan alpha. Tan alpha, direction of the resultant acceleration. What angle it makes with the radius vector? Tan alpha is equal to what? That is tangential acceleration by centripetal acceleration. So what about alpha? Alpha is equal to tan inverse tangential acceleration by centripetal acceleration. Tangential acceleration भी दिया हुआ है, centripetal acceleration भी दिया हुआ है. आप दोनों को डिवाइड कीजिए और tan inverse निकाल कर अल्फा निकाल सकते हैं. So what was the crux of the matter here? It's very simple. In non-uniform circular motion, speed also changes. That is all. तो उस स्पीड चेंज होने से बहुत सारी चीजें हो जाएगी, जैसे अभी मैंने कहा कि मोमेंटम चेंजेस देयर इन यूनिफॉर्म सर्कुलर मोशन, यहां भी मोमेंटम चेंज होता है। फोर्स जो है नेट फोर्स, अब नेट फोर्स का डायरेक्शन ये ए का डायरेक्शन है, रिजल्टेंट एक्सेलरेशन का डायरेक्शन है, सेंट्रीपिटल फोर्स का ये डायरेक्शन है, टेंजेंशियल फोर्स का ये डायरेक्शन है। अगर टेंजेंशियल फोर्स निकाला चाहिए तो एम ए टी, अगर सेंट्रीपिटल एक्सेलरेशन चाहिए तो एम वी स्क्वायर बाय आर, नेट फोर्स भी निकाला जा सकता है दिस स्क्वायर प्लस दिस स्क्वायर, so it becomes very very easy. Now see here, in uniform circular motion I said magnitude of speed is constant, but here magnitude of speed changes, obviously ये speed change हो रहा है, that gives rise to tangential acceleration. And there I told you that magnitude of momentum remains constant, but here magnitude of momentum changes because magnitude of momentum is m into speed, that changes because speed changes. So this is very simple, can do it now. Yes, it is tangential acceleration is there, there is centripetal acceleration continues to be as it was there in the uniform circular motion. इन दो का रिजल्ट निकालने से हो जाएगा acceleration. इसका अल्फा भी निकाला जा सकता है, what angle it makes with the radial line. Also you can make find this angle also, उसमें कोई नहीं है, ये एंगल जो है tan अल्फा सेंट्रिपेटल एक्सेलरेशन बाय टेंजेंशियल एक्सेलरेशन। लेकिन यहाँ तो अगर अल्फा यहाँ से डिफाइन होगा तो टेंजेंशियल एक्सेलरेशन बाय सेंट्रिपेटल एक्सेलरेशन tan इनवर्स। ओके, नाउ fourth point. Fourth point. Okay, let me develop an example. Let me frame an example for non-uniform circular motion. The example is like this: a particle moving in a circle. Let me suppose a particle moving in a circle in a radius of 20 centimeters. Let me make it 20 centimeters, and the speed I will make it time dependent so that speed changes. So I will make a mass of the object as 1 kg. I want to find many things. Maybe that will make the non-uniform circular motion clear to the students. Okay, it's a particle moving in a circle. This is a particle moving in a circle of radius r. It's a particle here moving like this with speed v. That is 2t, let me suppose, because I want to make it time dependent. And this is a center C. This is centripetal acceleration. That is v squared by r, of course. Okay. And the mass of the object is let the mass of the object be 1 kg. Let the mass of the object be 1 kg and radius of the circle. And radius of the circle is or equal to 20 centimeters. Okay. Let it be 20 centimeters. Okay, what are the questions that could be asked to make the things clear? Question: what is tangential acceleration? It's a non-uniform circular motion because speed changes with time. What is tangential acceleration? Second question, what can be second question asked? What is centripetal acceleration? AC. मगर वो तो चेंज हो रहा है, जब स्पीड चेंज होगा तो एसी भी चेंज होगा। देखिए ये स्पीड चेंज हो रहा है तो एसी भी चेंज होगा with time because speed changes. So therefore I should make the question, what is AC at t is equal to 1 second. इसको 1 second पर निकालना पड़ेगा. C, what is net acceleration? D, what is tangential force? What is centripetal force? What is net force? सब चीज निकालना पड़ेगा. Okay, let me start with A. What is tangential acceleration? Okay, now v is equal to t, rate of change of speed dv by dt is equal to 2. Differentiation करके this is tangential acceleration. Finished. खत्म हो गया. B, it was A. What about B? B is, what is centripetal acceleration? AC is equal to V square by R. What is V? What is V? But V at 1 second. What is V at 1 second? Directly read from here. 1 second. V is equal to 2 into 1, that is 2. So V is 2 square by R. What is R? That is 20 centimeters. 20 10 to the power minus 2. It is 4 by 20 into 10 raised to the power minus 2. It is 4 5. It is 1 by 5 into इसको ऊपर लेकर के 100. It is 20 meters per second square. Finish. दूसरा भी कर दिया, ये भी कर दिया. V square by R फार्मूला लगाकर हो गया. What is the net acceleration? Net acceleration. अब net acceleration की बात आएगी. Okay, let me rub it off. Net acceleration. Net acceleration जो है A net, that is root of tangential acceleration square, centripetal acceleration square. What is tangential acceleration square? That is 2 square plus 20 square. It is root of 400. 4 plus 400. It is root of 404. हो गया ये भी. What is tangential force? That is mass into tangential acceleration. Mass is 1 kg and tangential acceleration is 2. That is 2 Newton. ये भी हो गया. What is centripetal acceleration? That is mv square by r. That is m. Okay. क्यों पहले ही निकाला है? Mass into centripetal acceleration. Mass is 1 kg. What is centripetal acceleration? That is 20. That is okay. 20 Newton. What is net acceleration? What is net acceleration? Yes. What is net force? F net. That is root of, yes, ft square plus fc square. That's again root of 2 square plus 20 square. That is again root of 404. It didn't make any difference because mass was 1 kg. That's why net acceleration and net force is the same in magnitude, of course. Okay, what is the direction? Alpha, tan inverse. What is the net force direction? It is net force. What it makes with the radial line? Alpha. When there are two forces acting on the object, tangential and this, then of course there is the net force is not toward the center. It is making some angle with the radial line. So alpha is tan inverse ft by fc. That's alpha is equal to tan inverse what by what? What is ft? Yes, ft. That's 2. What is fc at t is equal to 1 second? T is equal to 1 second. What is that? That's 20. Okay, that's alpha is equal to tan inverse 1 by 10. That is the answer. Easily done. Easily done. So if you concentrate just for a while, what it really means, a particle moving in a circle, in uniform circular motion, speed remains constant. In non-uniform circular motion, what simply happens, the tangential velocity, speed also changes. When speed changes, there must be tangential acceleration. So in case of non-uniform circular motion, acceleration has two components, tangential component and radial component. Now if somebody asks you, does the kinetic energy change in non-uniform circular motion? The answer is yes, because there is a tangential force. That force has the same direction as the velocity, therefore it will speed up the particle. So that will do work. And centripetal force will not do work because that's perpendicular to velocity. But here the tangential force will do work and the speed increases. And work is done by the tangential force. So all these things now you can do yourself. But the base concept is this. Thank you again, students. But don't forget to subscribe to my channel, Tantray Sir Physics Classes, and download my app, Tantray Sir Physics Class. Thank you.